Hello and welcome everyone to the Create Compelling Analytic Experiences for Your Applications with Oracle Analytics Cloud webinar. My name is Tara Van Cleve and I'm a Marketing Event Manager for the Developer Initiative here at Oracle. Today we're excited to show you Oracle Analytics Cloud's developer capabilities and the power of the Semantic Model. We'll be recording today's session and you'll receive a link shortly after the webinar concludes at the same email address you registered for today's event with. If you have any questions during the webinar, please ask them in the Slack channel and we will answer them throughout the session. The link to join is bit.ly/join_the_Slack. And once you're in, you'll land in the general channel. From there, you can search for webinar/OAC-0428 to reach our dedicated space for Q&A today. Today's webinar will be presented by Brett Grinslade, Senior Director of Product Management for Analytics Platform, Pravin Janardhanam, Director of Product Management for Analytics Platform, and Mike Duran, Senior Principal Product Manager for Analytics Platform. So without further ado, I will turn it over to Brett.
Thank you, Tara. Yeah, I think we'll go ahead and get those slides going. My name is Brett Grinslade, and we're here to talk to you today about using analytics as a backbone to build more compelling applications. Here at Oracle, our mission is to help people see data in new ways and discover insights and unlock endless possibilities. So, one of the things that we're trying to do in the analytics platform is make it so that developers can do even more with the data they already have. So when you're trying to build an analytic application or enrich your applications with analytics, one of the things that you're going to need to do, well, you'll really need to do three different things. First, you're going to have to do some kind of data management. You may already have a database. You may already have data being created in different source systems like MongoDB or a data warehouse. You also probably want to start investing in data science. But finally, to expose that and to make that available to your users, you're really going to want to invest in data analytics. And what that means to us is creating different ways to view data to gain insights. So to kind of zoom in a little bit on what that means is you'll have a bunch of different components. We're not going to cover all of these pieces in today's session. There's all kinds of sessions from the DevRel team to go in these different pieces, but we just want to give you an idea of what some of the elements might be to a sort of a comprehensive solution for your application. You may have data coming in from a streaming system. You may have data land into a lakehouse or a warehouse of some kind. We're going to focus on the analytics piece. That's the ability to translate that information into something that's insightful and meaningful to your end users. So if you go to the next one. This is an example of some of the components that you might use. So on the far left, you might have data coming in from other applications, sensors, social media, your own application generating information. You're going to do some kind of data ingestion to put that into your system. Maybe you're writing directly to your database and you're going to be loading from that potentially. And we're going to, again, focus on that analytics piece. That's really, for us, that's the connection between the raw data and what people or machines or applications are going to use to make that data insightful and meaningful. So we have kind of one more overview part before we jump in, which is to give you kind of framing of what this discussion is going to be about. Is on the far right here, what I have is an example of different kind of experiences you might have. You might have application that's driven from data. Maybe you have to take action because something happens, you get a notification or an alert. You may have some visualization that shows you how something's coming together. You may have, the rings on your watch as an example, or you might have like something like a stock ticker showing a trend, and you want the users to understand that information. And then you might have machines or algorithms that also need to read that data. So there's really kind of different modalities. We're going to kind of focus on the first part about that, which is really delivering those insights to your users. And the part that we're going to start with is a semantic model. This is a layer of your application that you may not have today. And what it really does is it lets you take concepts that are meaningful to the user and translate them into rich queries to the backend data sources. And really think of it as like almost like a data API, which is a layer between what you're trying to explain to your users and what the data represents. And the nice part about it is, as an application developer, once you invest in the semantic model, you'll be able to make changes to your backend systems. Maybe you're going to changing information, maybe you're going to change aggregations, maybe you're going to be storing data differently over time. The semantic model can insulate your application from that and increase your time to market for new insights and information to your users. So with that, I'll hand it over to Pravin, who's going to kind of jump in and kind of describe what it means to go build a semantic model.
So I'll be covering Oracle Analytics data model strategy, followed by some introduction to semantic models itself, and followed by that the new semantic model language that we are introducing and the new semantic modeler that's coming up late next month. So our strategy with analytics data models stems from the need for self-service and governed analytics. We believe that there is a need for governed data models where IT brings the data from multiple sources or configures your analytics systems to access directly where the data resides, and build a semantic model on top of it to provide masking the data complexity so that the end user sees the business view of the data, right? And from a self-service standpoint of view, the users can bring their own data sets for their own analysis, or they can blend that data sets or join the data sets to create self-service data models on top of existing governed semantic model, which provides a single version of truth. So as you can see here, you have the governed semantic model on the left, where it brings data from multiple sources. That is our semantic model, predominantly our topic for today. And then the self-service data sets on the right, which we have significantly enhanced in the past year to be not just data sets, but they are indeed self-service data models as well. And from a strategy standpoint of view, long-term vision, some of these, data sets or self-service data models created by business users, there should be a path forward to migrate that to governed semantic models when that particular data model, created by a departmental user has value for the rest of the enterprise. There should be a path forward to move to governed semantic model. Okay, so why do we need a semantic model? Right. So, a semantic model, enables you to structure your data in a business-friendly way. Quite often, data is in third normal form, or for transactional applications, or a data warehouse data model, or it could be a data wall. Data can have multiple physical shapes, or it could be a multidimensional cube, right? So a semantic model enables you to structure this data in a way that the business understands the business, the business user understands the business, right? It enables you to add the business semantics to, the data that is coming from various systems. And you can also, have the capability to provide some governance rules for those data access, right? It essentially masks the complexity of the underlying data models and the access challenges that goes along with it, right? So on the top left corner, you see that if you see these enterprise applications, most of these semantics are at the application layer level, for each of these ERP or SaaS or any other applications. So when you move this data for analytic purposes for decision support systems, or you're creating a model that can go directly against those transactional data, you need, the semantic model is where, all your business logic and everything, plus the data structures go in place. So a semantic model is essentially, you can look at it as a conceptual model with data model plus business semantics. Okay. And so what are all some of the challenges that drive the need for a semantic model to provide a single version of truth, or a governed, way of providing that information, right? So your data can come from multiple sources, and these multiple sources could be disparate data sources or heterogeneous data sources, across various types of, data stores. The data could be at different grains. If you simply join that data, you're going to have a duplicate of measures on data for, data that is at a higher grain. Data for the same entity could be in multiple tables, right? So it could be as simple as, a third normal form table, or it could be just that if you have a high volume data, you decided to put that data year-wise into multiple tables. And each of these entities can in turn play, it may have the same data, but it can play different roles, right? And when you think about the logical aspects of a semantic model, that's where most of your business logic or, business rules go into play. You define your measures, calculations, who has access to certain data and who doesn't, and hierarchies that define your data structure and the business rules that go along with it, right? In addition to that, as I mentioned earlier, your data come from multiple systems. There are certain grain of the data you may want that data to go to an S-based cube or an analytics view. And if the data is detailed, it has to go to a detailed level. So that's known as aggregate navigation, right? So that in turn leads us to this dynamic source selection. So the end user doesn't have to think about where they have to write these queries, where the query should go. It's just the same single unified simple experience that they see from a presentation level, but the analytics engine decide which data source applies to that specific query. All of that is modeled in a semantic model, right? And the presentation layer is just a simple organization of elements in a way that you define these entities the way the business understands it, plus localization and other aspects. So in addition to all these, there is the governance aspect. So who can see what objects at a table level or at a column level, and also from a data standpoint of view, the row level security, data filters. Quite often you may have different types of users or different types of requirements for queries where some of them need to go through a tiered access. If you're using Oracle ADW, you have these 3 services of high, medium, low. You can choose which users or which queries or which roles get access to this tiered access to these data sources, plus some governance aspects on query generation, query cancellation, if it is running runaway queries and stuff. Okay. So what is in a semantic model? So on the left, you have these query clients. It could be from mobile, Oracle Analytics dashboards or Oracle, Analytics embedded into enterprise applications, or which Mike will be covering shortly. So the consumers could come from various portals or various access points, right? And then you have these data sources from databases, cubes, SaaS applications, files, and whatnot. And the semantic model bridges the request from consumers to the data sources, the mass, the complexity of the data sources, when to query what data sources and stuff. And how does that happen? Essentially, you have 3 components within semantic model. For anyone who have been building semantic models in Oracle Analytics, it has been there for the past 2 decades. You would know that there are 3 different layers: the physical layer, the logical layer, and the presentation layer. Each has its own, serves its own purpose, has its own purpose. So in the physical layer, you directly map to these data sources. The logical layer is where most of this dynamic source selection that I mentioned earlier happens, right? Your data, whatever shape it is, structured, unstructured, or it's in a multidimensional format, all of that gets translated or converted into a dimensional format in the logical layer. And then in the presentation layer, they are presented to consumers as role-based subject areas. Okay, taking a step back there and compressing that, so you'll see that the semantic model is indeed the brains behind the Oracle Analytics query engine. And how is that semantic model defined? They are defined using semantic model markup language. We'll see that soon. And so you have a way to define these using SMML directly, a semantic model markup language directly, or you can use a semantic modeler if you prefer to use a graphical interface. Semantic modeler is a new tool that we are introducing, which is tightly integrated with Oracle Analytics, and with a graphical interface defines the SMML. And that in turn gets created and deployed as semantic models in Oracle Analytics query engine. Right? In addition, we are also introducing the capability for a tight integration of Semantic Modeler with Git for multi-user development. So your SMML is basically your design time representation of your semantic model, and you're all, for anyone working on semantic models in Oracle Analytics right now, you are all familiar with the RPD file, which is a binary format, which is basically the runtime version of the semantic model. Okay, so from now on, we'll focus on the new semantic modeler, and as well as the semantic model markup language and the development process that go along with it. Okay. So the new semantic modeler is a completely, it's a browser-based modeling tool. And it is integrated with Oracle Analytics Cloud. So you have all the cool capabilities of Oracle Analytics, things like the state of the art search. Everything has been streamlined within Oracle within Semantic Modeler. It has a tight integration. I don't know if you can see in the screenshot, but later we'll see it in a demo. On the right side pane, what you're seeing is the Git actions. So it has a tight integration with Git. So pretty much all the common functions in Git, like pull, push, creating a branch, creating feature branches, and merging them with master, all of that is available from within the Semantic Modeler UI. Okay, and every object that you create here behind the scene is stored in Semantic Model, markup language, and we'll see that here. Okay, so what happens, essentially what happens is that every single object that you create in all the three layers, the physical layer, the logical layer, and the presentation layer, they are all stored behind the scene in SMML, right? And SMML is based on JSON. So if you see the file itself, the file will have a .json notation. And the granularity of the files itself is at the table level. The in the physical layer, it's the physical level. In the logical layer, it's at the logical table level, and then the presentation layer, it's at the presentation level, right? And the references have been, simplified to use fully qualified names, and object names match what you see in the UI. We'll see all of that in the demo, right? So here is an object that I'm seeing. On the left side, you have the graphical interface. It's in the UI, and the right side is the same object definition in SMML. Okay. So in essence, what happens in Semantic Modeler? So today, if you have an Oracle Analytics model, you'll have it in as a .rpd file. So you can ingest this RPD file in Semantic Modeler, and behind the scene, what happens is that there is an RPD to SMML generation, which converts that RPD file into hundreds or thousands of SMML files behind the scene. From there on, any development that you do in Semantic Modeler is happening, on top of these Semantic Model markup, SMML files. Okay, you can edit these files directly, or you can use the UI. But when it comes to deployment, Oracle Analytics Query Engine still requires an RPD file. So the SMML files are converted to RPD and then published or deployed to the Oracle Analytics Query Engine. Okay. So this is basically the right pane that I said earlier. So as you can see here, the integration with Git is is available from within Semantic Modeler. And once you configure the Git integration, you'll see this right pane get activated. From there on, any changes you do will be tracked in the Git pane itself. Okay, so a simple development process will be like, okay, you have Oracle Analytics Cloud integrated with Semantic Modeler integrated with Git. So your RPD can be read from from the Oracle Analytics Query Engine, or it could be an RPD to an SMML file. From there on, you have the main branch. From the main branch, each developer can create their own feature branch or a developer branch as needed. Typical, Git development process, and then you merge your changes to main. And when it comes to deployment, all these SMML files are get converted to RPD and then deployed to Analytics server. Okay, let's look at the demo. So here, what I'm doing is, instead of creating a model from the scratch, I'm using an existing model that has been created, and I already have the RPD file. If you're an existing Oracle Analytics customer using Semantic Models, you'll have a file to import. So the RPD file that I mentioned earlier. So I'm importing that file. That in turn, asks me for the password for the RPD file, and right now that RPD to SMML kicks in, right? So what you're seeing here is the presentation layer of the semantic model, followed by the logical layer here. And all the three layers are represented as tab, and this is our physical layer, right? In addition, you also have the connection tab and the variables management and init blocks tab, for init blocks. So every object that you see here is a file behind the scenes. So I'm seeing this dim action object, and you can see, you can change the properties. Just you're, familiar with the existing Oracle Analytics developer client tool. I can also open the same object in SMML. So what you're seeing here is an SMML definition with SMML editor. Here I'm using the editor that is provided as part of the semantic model application, but you can edit these files offline as well. So I have a fact table, all the familiar features that are used to in a modeling tool, like I pulled a fact table to a diagram and I'm saying show direct joins. That in turn shows me all the joins to that fact table, right? So this is a physical diagram, and also the same information, at a logical layer, multiple physical, schemas could be superimposed. So I can also see a logical diagram. So in the logical diagram, you have, as you can see, the join definition has the join type as well. So you have, in addition, you also, one of the most commonly used feature is the show related, which is, predominantly used. You want to know what object maps to what. So that is integrated with a streamlined search interface there. And, from the search, you can go to any objects, which is what you saw, clicking on it, take you to that object. So in addition, you also have a new feature for lineage, showing that, showing objects, and its relationship across the 3 layers. The left one is the physical layer, the center one is the logical, and the right one was the, presentation layer. Okay. So as I said earlier, one of the significant features that we are introducing for multi-view user development is the Git integration. So, and integrating with Git is a pretty simple task. You just create your Git repo. Here I'm creating a Git repo in GitHub. And I'm going to copy the URL for my Git repo and paste the URL. Right? It's going to ask you for your credentials. I provide the credentials. And at this point, what is happening is all the hundreds of or thousands of files that is behind the semantic model got initialized to Git. So as you can see, within a minute, this has happened within a minute. I have 3 different folders here, one for each layer, the logical, the physical, and the presentation folders. In addition, I also have the variables folder for variables and init blocks. Okay. So I'm going to open the logical folder where I have this business model core, and I have all these dimension definitions, right? So I have dim AP aging bucket JSON, and also the dim approved status JSON here. So as you can see, SMML has a .json notation, since it is currently using JSON notation for definition. Okay. So from here on, any changes that I make, will be tracked in the Git panel. Right, so I'm going to create a feature branch right now for feature 1, and I'm also going to create another feature branch, feature 2, primarily because I want to show the merge conflict resolution. I want to mimic a scenario on how a merge conflict resolution will look like. Okay, so I have created 2 feature branches, and in feature branch 2, I'm just going to make a simple update here. Just going to say updated by developer 2, save it. So the moment I save the model, you see that immediately there is an unstained change that shows up. Hey, dim action has changed. Okay, so at any point in time, this is going to have hundreds of changes as you work throughout the day on your model. So you can right click and say, hey, show the difference, and it clearly shows you what is what was the previous state of that object and what what you have done right now. So I have staged those changes and I have committed it. So the commit is successful, right? And I'm just merging it to, and I'm just switching to master branch, as of right now, right? So if I go to, and when I switch to master branch, I picked, feature branch 2 and merge those changes to master. Okay, and I'm pushing those changes. Okay, so now, I'm switching to feature branch 1. From here on, I'm just going to, create a bunch of steps where to mimic a merge conflict. So there was a conflict that you just saw right now. There is a merge conflict right here because there is a, both developers, did the exact same change. And you can right click and see, hey, what is the conflict? So here you see that what is their changes, what is our change. Hey, there are 2, there is a conflict, so you need to make a decision. So in this particular case, I had conflict on one object, but I'm pretty sure that in real world development, you will see that a lot of conflicts. And in such cases, you have a familiar interface to resolve those conflicts. So all in all, what you're seeing here is that a tight integration with Git, where some of the most common Git operations, commonly used, they are all tightly integrated from within Semantic Modeler. Okay. So what are the key takeaways from what we have seen so far? Semantic Model provides a user-friendly view of the data. It includes the business semantics. It adds on to the business semantics from to the data models, or the data that is coming from multiple systems, right? So it translates the business analysis request to optimize queries, across all heterogeneous data sources. So in Oracle Analytics Cloud, Semantic Model is the way to think about it, is the brains behind the intelligent query generation. So as a developer, when you create these models, you have the control to define what this query generation would be. Okay, some of the configuration changes that you make in the semantic model determines how the queries are generated, whether the queries are going to source A or source B is dependent upon the configuration that you make in the semantic model. And all of that, all the configuration points are available within semantic model, and it's been used. Semantic model itself for Oracle Analytics is not new, and it has been there for the past over 2 decades, right? But we are, what we have introduced new is that the semantic modeling language, the SMML, to define those semantic models, and a new tool, the browser-based Semantic Modeler, which has a tight integration with Git for multi-user development. Those are the 3 new things that are coming up. That concludes my presentation, and I'll hand it over to Mike.
Thank you, Praveen. After the session that Praveen has just gone through, we've got a semantic layer, and we may have created that using the new semantic model markup language, SMML. We may have that stored in Git in source control. We have multiple developers working on that, making changes programmatically, making those changes based on any sort of dynamic business requirements that your particular use case requires. And this is the perfect foundation for your multi-data source analytics system. So what's next? Well, you're going to want to ask it questions. You want to get it to provide some insight into the business issues that you're having. And Oracle Analytics Cloud provides augmented natural language abilities to do just that. You can literally ask questions of your data and create compelling data visualizations, which will kind of show you any trends or clusters in your data that will really stand out and help you to solve those business problems. But let's take this to the next level, which is to really start to build your own analytic applications. So why would you want to do this? Well, building your own application will give you an optimized user experience. You can focus the user's attention on what's really needed to get the task done, as opposed to thinking, maybe I'll just change this query, or maybe I'll create a new query. You can provide a curated set of content to only show the users what's needed to understand what action they need to take. Because really that's what this is all about, right? It's about fast time to value or insight to action. So building applications with your analytics content, we have 2 different ways of doing this, which I'll go through today, and it really depends on the kind of use cases and requirements that you have. So first up, let's take a look at the low-code way of doing this. So this will use one of our other Oracle products called Visual Builder, which is a low-code development platform. It's what you see is what you get. WYSIWYG platform, which allows you to drag and drop a palette of objects onto your canvas, which forms your application. You then are able to quite easily build an interactive application. Each of those drag and drop objects has a property inspector, which allows you to set some of the properties which you would normally be doing in code, but you can do it within the Visual Builder IDE environment itself. It's got very strong support for mobile applications, particularly progressive web applications or PWAs. And the great thing about those is that they can take advantage of things like location services from your device, or even the camera on the device. And location services is one of my favorites because you can then capture the latitude, longitude, and then use that for filtering your embedded analytics. And we'll take a look at some of the examples later on. And where it's been really useful from an analytics perspective is that Visual Builder is extensible via web components. So we've built a web component, which makes it really easy to embed analytics into Visual Builder apps. So once we've got our semantic layer and we've created some visualizations within Oracle Analytics Cloud, and we've got them stored in our catalog ready to go, you would then navigate to our developer tools section within the OAC product, which is what we're looking at the moment. And if you navigate to the embed section, what it'll do is show you some of the references that you're going to need to use when you do embedding. So for example, we have the path of the object that we wish to embed. If you're going down the HTML route, then you can see where we have some script tags, which will give you links to the Analytics Embedding SDK. I mentioned that we have a web component for Visual Builder, and it's called Oracle Analytics Project. This is what it looks like. You can search for it within the web component library within Visual Builder, and you can then install that within your applications within Visual Builder or VB. And the whole life cycle is taken care of. If we put out an update, then you'll be flagged that that update is available, and you can use the lifecycle capabilities of VB to update that within your applications. So here we have an example of the Visual Builder UI, and you can see we have a number of sections. So on the left, you can see the sort of structure of our overall application. And then for a given page, we have the available components that we can add onto the page, such as heading, text, and there's quite a long list there. Underneath, this is really useful because this shows you the layout of the page itself. So here we have a grid row which contains a flex container, and then I've got Oracle Analytics embedded into the flex container. And then on the right-hand side, you can see the properties for the Oracle Analytics component itself. So here you can see the host and the project path, and I have some sort of checkboxes that I can use to set those properties as needed. VB will allow you to simulate the devices that you're working with for your project. So here you can see how it would look on an iPad. And that's kind of really useful. You can set the screen size, and then you can change the styling of your embedded components as needed to kind of optimize the real estate that you have on your intended use case. So these building blocks, if you like, can be used to create rich visual experiences, such as the one that we have here. And this is based on I think it's a Bootstrap framework, excuse me. And this CSS has been imported into the Visual Builder application. And some of these tiles are, using data, which is maybe coming from REST APIs or coming from databases. And then the two objects that we have in the middle are actually embedded Oracle Analytics components. And one of the great things about embedding content into a VB app from Oracle Analytics is that it's actually a reference to the content in the catalog. So what that means is that you can make changes if you wanted to within OAC, which would then be shown within the application without having to rebuild the application. So I can show you what that looks like in this little in this demo. So here we have like a radar chart, which I'm in OAC, and I'm going to change that to a natural language generation. Sorry, it was a donut. So now I've saved that within OAC, and because that's a reference within Visual Builder, if I then refresh my Visual Builder app, you'll see the annual revenue change to this natural language view of that. And I've not had to rebuild that Visual Builder app at all. So that gives you a lot of flexibility, as things may or may not change within a kind of dynamic business environment where you're using these custom analytic applications. And if you do need to see the code, then you can do that very easily. Visual Builder has 3 different options for the UI. So either the live view, which is kind of useful when you want to test your application without having to kind of build it and view it in a preview. The design mode, which is where you're going to spend a lot of the time when you're actually developing, and then the code, which you may want to go in and just check what's happening with your divs or your classes, or you may want to just kind of, sometimes it's easier to move some of the objects on your canvas, actually just kind of copying a block of code and then moving it around as needed. So let's take a look at a demonstration here, which we have of building a mobile application within Visual Builder and embedding some analytic content. So I'm going to be building a mobile application, and Visual Builder provides some wizards to get you up and running very quickly. We're going to be looking at sustainability data, and you can choose the navigation style. So we're going to go for the tab navigation along the bottom of the device, and you can give each of the tabs that we have, gives you 3 by default, but obviously you can add or remove those as needed. You can give those meaningful labels. So here we've got some CO2 emissions. Perhaps population data is going to be useful to look at sustainability, and then some reference sources that people may want to look at to see where the data is coming from. And then the next step of that is for each of those navigation panes is to say, well, what kind of layout do I want? So the dashboarding layout is quite a good one for analytics. So we're going to choose that for this particular application that we're building in this demo. So that will give me the sort of the scaffolding and starting point for my application. And you can see that we've already got the navigation pane on the bottom, and we have 3 placeholders on this page. On the page template, you can kind of see how that's been built up. And if I scroll down the available components, we have the Oracle Analytics project, which I can drag over into one of those components. And then on the right-hand side, you can see that the properties are now available for me to fill in with the information that we were seeing when we were looking at the developer tab within the Oracle Analytics canvas. So you put in the host information that you're working with, and then the project path, which you can get from your developer tab. You may want to choose different tabs or reference a different tab if you have more than one. And I'm going to, by navigating to the general attributes, I can then change the styling of my embedded analytics. In this particular case, we're looking at an iPhone, so I want to just kind of change the styling size there to make it look appropriately sized within that device. So here we have the embedded analytics, and you can see how easy that was. I don't want to show the filter bar. I may want to add some programmatic filtering, so I don't necessarily want my users to be adding filters using that method. So now I've added some additional content. So we have a performance tile, which is showing CO2 emissions for the whole world. And I can scroll down where I have another embedded canvas, but this one's going to be interactive. I'm going to allow my end users to find their location based on the device location services to find the emissions for where they happen to be. So I've got a default of Australia, which is probably the furthest place away from me in the UK. So I wanted to, be able to show a demo where I can change something. And here we have a button that says show emissions for my location. And that's going to use the device location services to get your location. Now we do that by using what they call an action chain. So the event, when you press the button, will run this action chain. So it's going to get the location services, populate the lat longitude coordinates into some variables. Then it's going to call a REST API with that lat long to then return a country code. And I can use that country code within my filter and apply that to my embedded OAC canvas to return the country. So let's see that working. This is kind of just showing you the format of, it's a JSON format of the filter that we're applying to the embedded OAC canvas. I'll just tweak this. So here we can see the preview. If you were doing this for real, you'd get a QR code that you could then use with your mobile device to see this actually pop up on your mobile device. So here we have the data loading. That's an interactive map as well. You can scroll around and zoom. I can then click that button to show the emissions from my location, and I'm based in the UK. So that's now showing that the emissions for the UK are 8.62. So there you go. That's kind of an end-to-end demo, if you like, of how easy it is to take content from analytics and then build a mobile application in which you can then deploy to your end users. All right, so the second method that we looked at was using kind of more of a coding approach, where you're just going in and editing, creating your HTML, your CSS for your styling, and your interactivity with the JavaScript. So using the Analytics Embedding SDK, there are three main sort of areas that you're working with when building your HTML files. So we've got the reference to this embedding.js, which is the link to the SDK. That's what brings it back into your DOM, so you can then start to interact with it. You then have a reference to the canvases. So whereas before we were doing that within the low-code environment, here we're actually just using the Oracle DB tag and setting these as needed. And then we have the required JS, which is what we use for library loading. So these are the objects that are downloaded within the embedding.js file. And then we have apply bindings, which is a knockout way of kind of linking your the data to what you're showing to visualize those data. So that's that kind of link there. And depending on what JavaScript framework you're using, then you're able to use the Oracle DB embedding tag. These are some of the options that you have. So you can see that we can set the project path and some of the project options. The project options are shown down below as the show filter bar. And these can all be set programmatically as well. So you can dynamically change these as needed, really. And then the filters is what we were looking at earlier on with respect to applying the latitude and the longitude to our embedding content. So let's take a look at a demonstration of how the code would change based on some use cases when you're creating embedded content with these sorts of technologies. So this is a little demo application that we have, which allows us to see a visualization on the top right. And then if I scroll down, you can see the HTML and JavaScript, which would provide that visualization. So I can say, I want to show the filter bar, and that's now showing the filter bar on my embedded content. And if I scroll down, you can see that we now have this .project options show filter bar true. So that's the bit of code which would allow you to see the filter bar. If I choose a different canvas and then apply some filters to that canvas, so in this case, I'm going to limit the date to June 2016, May 2017. You can see that some code has now been added to this, which is limiting the dates that my visualizations are showing. And if I change to the central and west regions filter, if I apply that, you can see that, again, the filter JSON that's applied and the visualization changes accordingly. So that's kind of just to give you a taster of the kind of code that you would need to add to your system to see those corresponding changes. And one of our partners, Clearpeaks, have been using this method to create their own application called Observation Deck. And the great thing about this is that they can create their own highly visual styled application, which embeds content that analytics customers have been generating, and then they can reuse it within the Observation Deck product. And as you can see from the quote along the bottom, that Clearpeaks have found that very useful to be able to reuse and leverage that investment that customers have. And as they say, they found that was a game changer from what they could do within Observation Deck and get up and running very quickly. And we have a link along the bottom there if you're interested to find out more about the Clearpeaks Observation Deck product. All right, so some key takeaways. So what you've seen is quite a lot of information there. So Pravin started off by showing the new web semantic model, and something that has been asked for many years is the ability to programmatically change that sort of content. And we're delivering on that with the Semantic Model Markup language, or SSML. Being able to store that SSML within Git and programmatically change it, have multiple developers working on your semantic layer, making those changes, merging them in, and then rolling that out using a true development development process. And then we spoke about how you can start creating custom applications with embedded analytics, which really is all about providing faster time to value. And hopefully, if you're a JavaScript programmer, you'll appreciate my in-joke on line 2. And then we looked at some of the embedding options for analytics, low-code options where you've got Visual Builder, which can really get you up and running very quickly with literally no code at all. using a visual graphic environment to build up action chains to access things like location services, and then apply that to your embedded analytics. And then if you are more of a developer, you can start to use some raw HTML and styling in JavaScript to build whatever application you want. Okay, so we have a little bit more information here about some upcoming events and feedback, and I think we'll be taking questions.
Again, we didn't show as many examples just because we wanted to cover like a broad range, but one of the loops that we've been able to do with some of our other partners we're working with and ISVs is you can really do fast prototyping in the OAC experience where you're building different visuals, and you can create that separation. Think of it like the separation from CSS and code. You can have people working on the data analytics, thinking of new ways to view the data, new ways to experience and enrich your application experience. And then with that kind of things that Mike was showing, that embedding experience, you can quickly onboard those into your application and quickly build experiences and have very fast time to market. So we can cover some more of those examples next time. So, well, a couple questions I wanted to answer live, Pravin. One question was about when you're using Semantic Modeler, how do you manage different users changing different aspects of the model? How do you do isolation or manage, user boundaries in the development side? Not end users running queries, but the development side.
With the Git integration right now, it follows exactly the same processes as Git. So there is, if you have a specific feature that you're developing on, you create a feature branch and you can isolate it from the main branch. It could be a developer branch where the developer wants to try something out without affecting the rest of the branches. So everything is based on the current existing Git processes.
And I think part of the question is, are there are they all in one repo, or how do you manage like if you want one developer only working on one part of the semantic model, is there a direct way to do that?
Yeah, they're all part of the same, semantic model repo. So especially in Git, once you have access to a repo, you have access to the complete repo. But your changes, is something that you can create a separate branch into it, so that it doesn't affect the rest of the branches or the mainstream branches.
Great. We'll answer a few more questions here live. One is, can you implement data level security with OAC?
Yes. That's a feature that's been there for over 2 decades now, and that will carry on with the new semantic model definition. Yes.
Yeah, and I think to elaborate on that a little bit, it has a lot of rich controls. You can do it based on users' roles. You can do it based on driven from data properties. You can actually even control whether people are able to query different aspects of the data. So whether you're coming through an API or whether you're doing something in a self-service experience or in that embedding experience, all those data security are managed at query time by the OAC query generation engine. And that's actually one of the main benefits. You can imagine if you have a multi-tenant environment or something like this, you can implement all of that security in the semantic model. And then that can carry through to even if you're looking at, say, historical data and those kind of things. So it can apply to any types of queries that you're running against the backend. And another question is, can you develop data in OAC with high volume data without an RPD and ADW? I mean, the answer is, well, RPD is really what we're showing here is how you build a semantic model. So I think in this case, we're discussing using the semantic model to access data. There are ways to create data sets and do some of the stuff that Mike was showing without a semantic model. Having said that, I think if you're building an application experience, let's say you're a SaaS vendor or something, you're building a SaaS application, you probably really want to use the richness of the RPD to extend that. But certainly you can query data in non-ADW sources. We do run queries against ADW, but you can use other tools and other systems. We support a broader range of systems. We have a lot of customers recently just started using the new Dataflow interactive services as something that's a new area that people are starting to look at. So there's a lot of options that you can do, and it doesn't have to be on ADW for sure. There's another question, Pravin, will the semantic modeler replace the RPD?
So the semantic modeler, in future will replace admin tool. Okay, so RPD is the binary version of the semantic model. So as of right now, RPD, as we saw, RPD is still there, SMML is the design time version, design time format of Semantic Model. So one is the tool here. The Semantic Modeler is the tool. I think you may be asking, will Semantic Model replace RPD? No, Semantic Model, RPD is a runtime version of a Semantic Model, a compiled version of Semantic Model.
But we definitely would say that SMML will be the new way that we expect everyone to build their semantic models in the long run. And whether you're using our web semantic modeler tool, or whether you're using, if somebody develops third-party add-ins or tools, or if you're just editing this SMML directly, we're really moving to this source code first model so that you can build a semantic layer. And we do have some partners and internal teams that are actually generating that SMML dynamically with their application. And so you can actually, it's just a JSON format that you can create and write to, and then you can, essentially, when you publish or create the RPD from that runtime artifact, think of that as like a publishing or compilation step to translate those semantic objects into the runtime that we use for the query generation.
All right, well, that concludes today. So thank you again, everyone, for joining us. We hope you have a great rest of your day and to see you again next time.